13.2. The first thing we're going to do is talk about some vocabulary with angles and how to find coterminal angles. And then we'll talk about how to measure an angle in terms of a radian, which is a whole new concept. And most of trig is done in radians. Radians make certain formulas work out really nicely. So in particular with like sector area, and so we use radians almost, most often in trig to measure an angle. So let's start with some basics for vocabulary. The objective would be to find coterminal angles, which we'll get to. But the way this whole rotational system works is we have an XY coordinate plane, and that's what you're used to. I mean, you can plot points. This is the x-axis, this is the y-axis. So we can move, in our rectangular coordinates, we move right, left, up, down, and we have coordinates. So we still have our XY coordinate plane. Okay, but now what we're going to do is we're going to how do you create an angle and rotate? Well, we always start here, and so we'll draw over this, draw a ray. You remember that from geometry. A ray has an initial point and an arrow in a direction, and then we rotate, for example, and from here to here. So I'll draw to show the rotation. So that's how you create an angle in the coordinate system. And this is called, for the angle, this is called the initial side, and this is called the terminal side, where you end up. Terminal side. So we have, and we always start with the initial side on the x-axis. The vertex is at the origin. This is the origin at 0, 0, and we rotate from the initial side to the terminal side, and that's how we create an angle. And we can rotate in the positive or negative direction. The direction I showed you is the positive direction. If I rotate the other way, it's the negative. You can have a negative angle. And then in this, so this is 0 degrees. This is 0 degrees. This is 90 degrees. If you rotated to there, that would be 90 degrees. This is 180 degrees. This is how many degrees? 180 plus 90 is 270 degrees. Okay, so that's how we create angles in the coordinate system. Now, coterminal means, to find a coterminal angle, the word coterminal means the terminal sides coincide for angles. Coterminal angles. Two coterminal angles are the terminal sides coincide or overlap. I'll show you what I mean. And to find coterminal angles, basically you end up in the same place. So to find coterminal angles, you would basically add or subtract multiples of 360, because you know that 360 degrees is all the way around. So when I write 0 degrees here, I can also write 360. Those are actually coterminal, 0 degrees and 360. So you could find a bunch of them. You could go on to an infinite number of coterminal angles, as long as you add or subtract, depending on which direction you're going, multiples of 360 degrees. Then you will have your coterminal angles. So let's do an example. And now I'm going to add here, if we're in degrees, it's 360 degrees. Add or subtract. If we're in radians, which we'll talk about in just a second, add or subtract multiples of 360 degrees, or, and here's the new concept for today, or 2 pi radians. Because those are equivalent. A full lap around the circle is 2 pi radians. In other words, they're 6.28, right? 2 pi is the same as 6.28, right? Because pi is just a number. Even though it's a symbol, pi means 3.14 roughly. So there's 6.28 in any circle. You can wrap 6.28 radius lengths around the outside, around the circumference. no matter how big the circle is. And so that's measuring an angle in radians. So these things you have to know are equivalent. 360 degrees and 2 pi radians are the same. So let's go back. An example of a coterminal angle would be this. If I said, give me the two coterminal angles to 10 degrees, what would you say? In other words, what's the same way of naming 10 degrees where you end up in the same place? What's that? Good. 370 degrees, that you end up in the same place. Or what if I rotate the other way? If I start, so 10 degrees is, if I were to draw a picture, 10 degrees is right there. Sometimes you'll be asked to draw a picture of an angle. There's 10 degrees. So if I rotate all the way, if I rotate 10 degrees and I go all the way around back to where I started, that would also be 370 degrees, right? You end up, it's coterminal, you end up at the same place, 370. What if I start, you always start here, and I go back this way? How many degrees is that? Negative, do you see it? Good, negative 350. So all of these angles end up at the same place, and that's all they're coterminal. 10 degrees, 370 degrees if you go an extra rotation in the positive direction. If you rotate in the negative direction, you would go, you would start here and you would go around negative 350 degrees. And that's how you would draw a picture showing it, negative 350. Okay, now let's go back to our radians concept and really nail this down. And I'll tell you how to convert back and forth from radians to degrees. So the definition, it's literally in the new Common Core State Standards, like to really understand the definition of a radian. Radians are, when you say an angle is 2 pi radians, it means the number of radii plural for radiuses, the number of radii you can wrap around the arc formed by the angle. In other words, in an angle, for example, of 360 degrees, you could wrap 6.28 radii around the outside. Let me draw you a picture. Let's do an example of an angle that's 2 radians. So here's a circle, and here's where, so that means 2 radians is about right here, because remember all the way here is 3.14 or pi radians. All the way around is 2 pi radians. So to here is just pi, or 3.14 radians. So 2 radians, see, if this is r right here, then that means around the outside I can wrap 2 of those r's, and I'm going to go again, about 2 of those r's around the outside. And that's what, so this angle is 2 radians. From here to here is 2 radians. And when we say the angle, that's like the central angle. And so you could wrap 2 r's around the outside. Okay, so, and that's why, another example, you know that if I have a circle and I go all the way around, okay, the circumference of a circle, you already know, what's the formula for the circumference of a circle? 2 pi r. 2 pi r. So see, if you forget, that r means radius. So it's basically saying 2 pi radians is the measure of the angle that starts from here and goes all the way around. 2 pi radians is the same as 360 degrees. Because the formula I'm going to give you next is based on that. It's a proportion. We can convert any degrees to radians back and forth using just doing a proportion. As long as you know 2 pi radians are the same as 360, here's the formula, and then we'll practice a few. So to go from degrees degrees to radians. I'll give you the formula. I'm going to show you an even better way though. We'll get there. You multiply by pi over 180. Because those are equivalent. That's like multiplying by 1. And to go from radians to degrees, you multiply by the inverse, which is still 1, multiply by degrees over radians. It's really easy to remember because if you want your answer in radians, make the pi on top, because radians are typically measured with pi in it. If you want your final answer in degrees, make sure the degrees are on top. 180 degrees and pi are equivalent. It's like saying an angle to there, that's 180 degrees, right? Or that's pi radians, meaning about 3.14 radius lengths you could wrap around. So you're just multiplying by 1. Could I say 360 over 2 pi? Could you do that? Sure. Yeah, but that's just bigger numbers, and then it takes longer to simplify. If you want, you could say multiply by 360 over 2 pi. But why? This is simpler. So, okay, we're gonna just wrap up with some examples of converting, and that will be all for today. So I'm just gonna write convert. So whatever I give you, you convert it. So number 1 is if I say 135 degrees, and I want to convert that to radians. So you go like this. Eventually you're going to think about it in terms of a unit circle, and you'll answer right away without having to even do this work. But for now, you multiply by pi over 180. You must simplify this fraction. What divides them evenly to 135 and 180? 5. Okay, we can start there. So 5 goes in here. 20, 35, 7 times, and 5 goes into here, 336, correct me if I'm wrong. What else? Let's keep simplifying. What goes into 27 and 36, assuming that's right? I think 9, right? 9 goes into here 3 times, and 9 goes into here. Good. So it's 3 pi over 4. Eventually, we're going to look at the unit circle and the geometry in it, and you'll just know to go from 135 degrees is 3 pi over 4 straight away without having to do this arithmetic. Let's try another one. Let's do negative 50 degrees. So we're rotating in the negative direction. So our answer is going to be negative. I'll just put that at the end right there. But I want it in radians. So what do you multiply by? Pi over 180, and you have to simplify. So what divides in evenly? 10. So good. So that's negative 5 pi over 18, and I think that's it. That's actually done. And that one is actually not on the unit circle. Let's try this. Let's go the other way. 5 pi over 4 radians. What do I multiply by to get degrees? Times 180 degrees over pi. And now look, what the cool thing that'll happen is your pi's will always cancel when you do that. And so it's, it's easy to see you end up in degrees. 4 goes into 180. You would simplify 5 times 180 over 4. Or you could do that on your calculator, and you'll get 225 degrees. So 5 pi over 4 radians is equivalent to 225 degrees. We're going to do one last example. Let's try pi over 10 radians. I would multiply by, I want my answer in degrees. Good. Multiply by 180 degrees over pi. So those cancel. 180 divided by 10 is, so you get 18 degrees. 18 degrees. And those are equivalent when you're measuring an angle, which is the point. Measuring angles in radians.